Alrighty, Nikita is a Ruby on Rails developer and an open source contributor. He likes cycling and camping and is excited that the summer is almost here. Let's give him a warm welcome.
Hi everyone, last talk of the day before the keynote. Hoping to keep you entertained. There will be things on the slide that are moving. I'm also be sharing something I learned or I did. So yeah, let's begin. Rails 7.1 introduces native support for composite primary keys. It's a feature that allows you to manage complex data relationship. In this talk, we'll explore what this feature entails, its practical applications, and show how it's used in the real-world applications like at Shopify. A little bit about myself. I'm Nikita. I'm a Ruby Rails developer. I occasionally contribute to open source, Rails specifically, and I'm part of the Rails Triage team. I live in Ottawa, Canada, not far away from here. I'm part of the Ruby on Rails infrastructure team. We have our booth here. Please come talk about any topic you have in mind, specifically composite primary keys or tenant-based sharding. We are participating in Hack Days tomorrow. That's also a great place to take part in any activities we have to offer. In this talk, we'll start from defining the term composite primary keys and discussing their impact in database design. We also look into some real-world examples where composite primary keys can be effectively utilized. Next, we'll explore the role of composite primary keys in multi-tenant applications, using Shopify monolith as an example of a tenant-based application. We'll draw some parallels between composite primary keys and tenant-based sharding, which is a strategy to scale multi-tenant applications. And we'll finish with examining how Rails 7.1 supports it and what tooling it provides to support composite primary keys. Let's start from fundamentals. We'll cover definition of the composite primary keys. We'll look at some examples and learn when and why we could use them in our applications. Before we begin, I'd like to mention that having the capability to utilize composite primary key doesn't necessitate their use in every scenario. The decision to implement composite primary keys should be driven purely by your database design. However, when such design decision is made, be rest assured Rails will be there to support it. So composite primary key is a type of a primary key that is made up of two or more columns, which together guarantee the uniqueness of a row in a table. They play a crucial role in database design, especially when it comes to representing models and relationships that cannot be accurately captured with a single column key. Let's quickly go through some real-world examples of entities that can be identified by combination of its properties. For example, in car entity, a combination of make, model, and year can uniquely identify a car. For a book entity, a combination of author and the title can distinguish each unique item. Let's turn our attention to an actual practical example where we can effectively implement composite primary key. Join tables are a natural field for a composite primary key. By using composite primary key made up of two foreign keys to the two related entities, we can ensure the uniqueness of each relationship. Let's consider an example, a blogging system. In this system, we have post table and a tags table. A single post can have multiple tags. A single tag can be associated with multiple posts. To represent this many-to-many relationship, we would typically have a post tags join table. The primary key for this post tags table could be a composite primary key made up of blog post ID and tag ID. It will ensure that each combination of post and tag is unique, representing the relationship. When choosing the order of columns in the composite primary key, such as tag ID, post ID versus post ID, tag ID, it's important to consider the types of queries you'll be running most frequently, because in some database engine, it will impact performance on certain operations. So in this section, we learned that join tables are the most common example to use composite primary keys. Composite primary keys are not suitable for every single table, and use of composite primary keys should be driven by database schema design. Let's talk about composite primary keys in multi-tenant applications. this section, I'd like to talk about Shopify monolith being an example of a multi-tenant application, how altering primary key on a table can improve performance of certain operations, and we'll explore trade-offs in using composite primary keys. One of the Rails convention is that all tables have an automatically incrementing integer primary key called ID. That means for a typical Rails application, most data is stored on disk strictly in the order rows were created. For most tables in Rails application, that works just fine and easy for application developers to understand. In case of Shopify, however, there is an additional layer of organization. Every record in almost every table at Shopify semantically belongs to a specific tenant, a shop, and this association is facilitated through inclusion of a tenant key in every tenant-related table called shop ID. In majority of the use cases, the pattern of row access at a table can significantly differ from insertion pattern. This is particularly true for Shopify monolith due to its multi-tenant architecture. A single database instance contains records from multiple shops. With a simple auto-incrementing primary key, table insertion results in a mix of records from various shops. However, when it comes to querying data, most queries are typically focused on records from a single shop at a time. So by prepending the tenant key to the making composite primary key, we will alter data layout on the disk. This makes it easier to select records that belong to the same tenant as they're now grouped together. Covering data layouts on disk is beyond the scope of this presentation, so let's use a bookshelf analogy to illustrate why querying records in bulk by tenant becomes more optimal when we include tenant key in our primary key, thereby creating a composite primary key. Imagine a bookshelf where books are stored in the order they were purchased. Inserting a new book in this case is straightforward. You simply find an empty slot and place the book there. This is similar to adding a new record to the end of the table in a database. But if you're asked to find all books by a specific author, you would have to go through each book one by one, checking the author's name. Even if you have a secondary index available that tells you exact location of the book, you'll still have to take time to pick them all from different shelves. This process can be time-consuming and inefficient. Now imagine a different scenario where the same bookshelf is organized with books grouped by authors. In this case, finding all books by a specific author becomes much more quicker and easier. You simply locate the section of the bookshelf dedicated to that author, and all the books you're looking for are right there. However, when the bookshelf is organized by author, insertion of a new book requires a bit more work. You first need to find the section for the specific author before placing the book on the shelf. So let's extend our bookshelf analogy a little bit further. Imagine now that the books on the shelf not only group by the author, but groups are tightly packed together, leaving no space between different author sections. In this scenario, inserting a new book becomes even more challenging. You can't simply add the book at the end of the section. Instead, you need to make more space within the section to keep all the books by the same author together. This might involve moving several books around, which is also time-consuming and inefficient. While the bookshelf analogy doesn't fully represent the complexity and diversity of actual database storage engines, I hope it provides a simplified perspective of how data organization can impact various operations. Just as the way we organize books in a bookshelf can affect the time it takes for us to remove, add, or pick the book, choosing the data layout on the disk will impact performance of records insertion, deletion, or updates. So we made a decision to switch one of our largest tables at Shopify called orders table almost 5 years ago. As I mentioned, it was a purely database decision before Rails supported it. As a result, we saw an improvement, a 5 times improvement on queries performance. There is a whole blog post written by the database team who performed the change. However, there was one notable downside that is worth calling out. We observed roughly 10 times degradation on inserts by switching to a composite primary key. Since most data is queried and updated more often than inserted, this trade-off was correct in our case. However, it's worth keeping in mind that if insert performance is something that is crucial for your application, using composite primary key may not be a suitable approach. So let's recap. Database tables in multi-tenant applications often benefit from the use of composite primary keys by including the tenant key in the primary key by prepending it. So composite primary keys may enhance bulk reads and updates, but at the cost of a slower insertion rate. Let's talk about similarities with tenant-based sharding. So tenant-based sharding is a strategy employed to scale multi-tenant applications. In this approach, data is partitioned based on the tenant ID, resulting in application data being spread across multiple shards. Crucially, all data belonging to the same tenant must live on the same shard. In scope of this presentation, I'd like to discuss two different designs for implementing sharding in a database system. So on your left, you'll see what I would call an integrated sharding solution. This is where the sharding solution lives within an app. This offers flexibility and control, but adds complexity to the application code, since often you will be the one maintaining it. And on the right is standalone sharding. This is the sharding solution which lives separately from the application, and the application connects to it as if it was a regular database. For the purpose of this presentation, we'll focus on the standalone sharding solution. One of the examples is a Vitesse, but also I had an insightful conversation during this conference where we realized that Postgres partitioning might be also a good example that implies the same requirements. Speaking of requirements, standalone sharding solution does impose one key requirement on the application, the need to pass tenant key in every SQL query. This is similar to how composite primary key requires every query to include all parts of the key. This will ensure sharding solution can correctly route each query to appropriate shard based on the tenant key. So implementing composite primary keys can be seen as a foundational, even though not a necessary step towards implementing tenant-based sharding. By including tenant ID in the primary key, you're already referring to your data on a per-tenant basis, which is a core concept behind sharding. This can make transition to a sharding strategy easier and more seamless when the time comes. So let's recap. Models using composite primary keys and tenant sharded models both include multiple columns in the queries. Implementing composite primary keys could be a foundational step, but a not necessary step towards a full sharding strategy. Let's look at what Active Record provides to work and support composite primary keys. In this section, I'd like to cover how to define a composite primary key in a Rails model, how to work with a composite primary key model, how to define a virtual primary key and what it is, and we'll talk about limitations, what's not to do when defining primary keys, or what to be cautious about. Let's imagine a table called travel routes, where each route is uniquely identified by its origin and destination. To create table, we'll use a create table macro and pass composite primary key as an array to the primary key option. In our travel route model, the primary key is a composite key made of both origin and destination. That means the ID of each record isn't a single value, but an ID of two values. And when we update or delete or reload a travel route record, Rails will construct a SQL query that targets record by using both origin and destination. There is a special case which is more common when an application decides to migrate an existing table to a composite primary key. Consider a table initially using a single column ID as a primary key. So when we want to transition this table to use a composite primary key, then that typically includes a tenant key, like in this example, blog ID. When ID is part of the composite primary key alongside any other column like blog ID, it leads to a slight collision, particularly when accessing the ID column value directly. When we attempt to access comment ID, instead of getting the usual single value integer, we receive an array. This array represents the composite primary key. To handle this situation, we might need to explicitly separate values of the composite primary key by splitting them into both tenant key and ID. To address this collision, this happens because Rails treats ID concept as an identifier and not as ID column accessor. So this is why having column named ID as part of your composite primary key makes it harder to get the value of the ID column. To address this issue, Rails introduces new ID column attribute alias called ID value. So on this slide, we can see how ID value method returns the value of ID column no matter what shape our primary key is. Let's look at the bulk loading of records identified by composite primary keys. Rails 7.1 extends where query method to support what we call query by tuple syntax. This is where to query composite primary key records in bulk, you can pass a hash where the key is a set of column names and the value is array of tuples of composite primary key values or identifiers. This structure allows us to specify multiple combination of origins and destinations that we want to query. When it comes to associating models with the composite primary key, Rails 7.1 adds a query constraints option to association to serve as a composite foreign key. In this slide, we're introducing a new association option in XF record called query constraints. This option acts very similar to how a composite foreign key would behave. So query constraints specify that a travel route review model route's origin and route destination will be the composite foreign key of the review that map to route origin and destination of the travel route model. And as we've seen previously, it makes the Rails to craft SQL queries that will address associated records by both its origin and destination. So as was pointed out previously, using composite primary keys is not necessary for supporting tenant-based sharding. In this slide, we'll create two related tables, orders and line items that are expected to be used within a multi-tenant architecture. Each table includes a shop ID column serving as a tenant key, which is a crucial part of data partitioning and ensuring data isolation between tenants. Rails 7.1 introduces a concept of a virtual primary key called query constraints. We can use it as a macro, specifying all columns we would like to use when it comes to querying, updating, and deleting records of a certain model. And as we saw previously, it will make the model behave exactly like if it was using a composite primary key without actually modifying schema. You might have noticed we didn't need any special setup apart from the macro on the model. This is because Rails is capable of deriving query constraints on association when models' query constraints have only two columns, one of which is the primary key of the model and the other one is tenant key-like column. Let's recap. So XF Record 7.1 natively supports composite primary keys. ID column as a part of the composite primary key adds complexity, and the query constraints option can be used as a virtual primary key, which is useful for tenant-based sharding. Let's conclude. Please use composite primary keys based on your database needs. Make sure it's suitable. Rails will support it. You should consider using composite primary keys when having a separate single column identifier is unnecessary and excessive, like in join tables, and multi-tenant applications with a lot of bulk reads and updates scoped per single tenant. You should consider using query constraints to make sure you include your tenant key in all of your SQL queries, or just in general to define any columns other than primary key in update, reload, and delete actions. As a general reminder, Rails core team reserves GitHub issue tracker purely for bugs. Discussions and proposals are better suited in Discord or Discourse. I'd like to thank all these great people for helping me reviewing, implementing parts of the feature, and continuing improving it. Thank you.